Hey everyone, today I'm going to be going over your Module 7 practice test. So number 1, we are going to complete the function table. So I have been given inputs, outputs, and the rule in the middle. When I am given an input, I'm going to put that input into my rule. So this is going to be 4 times 4. So my output is 16. 4 times 9, my output is 36. Now in the next one, I'm given the outputs and asked to work my way back to the input. So this means that my rule is equal to the output. So I'm going to divide 56 by 4 and I get 14. So for this one, I did 56 divided by 4. And then for this one, I have 4x equals 96. That means that I'm going to do 96 divided by 4, and you should get 24. In number 2, I'm going to do the exact same thing, only this time I'm using addition instead of multiplication. So for my input to output, I'm going to do 5 plus 8 is 13, and 11 plus 8 is 19. To work my way backwards, I'm going to have x plus 8 is equal to 510. So I'm going to do 510 minus 8, and I get 502. And then I'm going to do x plus 8 is equal to 763. So I'm going to do 763 minus 8, and I get 755. For number 3, I'm going to write an equation to represent the rule in the table, and then I'm going to fill in the last box at the end. So normally I would have this be a different color to fill in at the end. So first I'm going to check and make sure that my inputs go by 1. So again, we're not going to include this. So plus 1, plus 1, plus 1. So my inputs are good. Then I'm going to check my outputs. So my outputs are also going up by 1. That means I'm going to start with y equals 1x. Now I have to check my input to my output. So I'm going to start with this point right here. And I'm going to say, okay, y equals 1 times 5. Well, 1 times 5 is 5, and I need to get to 29, so I'm going to add 24. So on my rule, I'm going to add 24. So my rule is 1x plus 24. Now I'm going to plug in the number 12. So y equals 1 times 12 plus 24. My value is 36. 1 times 12 is 12, plus 24 is 36. For number 5, my inputs go by 1s. My outputs go by 2s. So I'm going to start with y equals 2x. And then I'm going to check, well, y equals 2 times 1. 2 times 1 is 2. To get to 16, I'm going to add 14. So onto my rule, I'm going to add 14. In number 5, it goes by 1s. And then my y's, or my outputs, go by 9. So I'm going to start with y equals 9x. And then when I check y equals 9 times 1, it comes out the way it's supposed to, so my rule is done. For 6, 7, and 8, I'm going to do the same thing, but now I've got an input value that's missing or an output value that's missing. So here I'm going to add 1. And then over here I've got plus 5, plus 5. So I'm going to start with y equals 5x. When I check my rule, y equals 5 times 1. Well, y equals 5 the way it's supposed to, so my rule is y equals 5x. So for 10, I'm going to do y equals 5 times 10 is 50. So in that last box is going to be a 50. For number 7, I'm doing plus 1, and then here is plus 3. So I'm going to start with y equals 3x. When I check my first value, y equals 3 times 5. Well, 3 times 5 is 15. To get to 19, I'm going to add 4. So 3x plus 4 is my rule. And I'm going to put in 12. So 3 times 12 plus 4, 36 plus 4 is 40. So in this last box It needs to be a 40. For number 8, I'm going to do the same thing, but this time I have an output instead of an input. So I'm going up by 1s here and 1s on the other side as well. So I'm going to start with y equals 1x, and then I'm going to check 15. So y equals 1 times 15. If y equals 15 and I want to get down to 11, I'm going to subtract 4. So minus 4 on my rule. Now for this last box, this output right here, this means that my rule, 1x minus 4, is equal to my output. So I'm going to add 4 to both sides and get x equals 68. So my input is actually 68 here. Okay, so that's writing function rules from a table. You find the change in the output, check your rule, and then add anything or subtract anything that is needed on your rule. The next two, I'm going to write an equation and then answer a question. So it says the table shows the total cost of buying K cookies. Write an equation to represent the relationship between C and K. Well, I have to know how many cookies I am purchasing before I know the total cost. So I'm going to fill in those spots first. They used K to represent cookies and C to represent total cost. So my values are going by 1s. On the inputs, they are going by 3s on the outputs. So I'm going to start with C equals 3K. And because I have labeled in my table and I know what my variables are, I can now answer the question. Because this is my final rule, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, etc. So now I'm going to answer the question. It says, using your equation, how many cookies can you buy for $252? Well, this information right here goes in the total cost column, and that's why we left this blank. So I'm going to put that in my total cost column. That means it goes in for C, not for K. So I'm going to have 252 is equal to 3K, and I'm going to divide by 3 on both sides. And 252 divided by 3 is 84, so K equals 84 cookies. Okay. Number 10 says the table shows the cost of rock climbing based on the number of hours and a one-time shoe rental fee. Write an equation to represent the total cost, C, of rock climbing for H hours. So here I'm going to count the number of hours that I spent rock climbing, and that relates to my total cost. So I am going to start with C equals, because C is total cost and H is hours. My inputs go up by 1. My outputs go up by 6. So I'm going to start with C equals 6H. And then if I check my rule this time, C equals 6 times 1. Well, C is then 6, so I have to add 9 to get up to 15. So my rule is C equals 6H plus 9. So now it says, using your equation, what is the total cost for climbing for 12 hours? Well, I'm going to put the 12 hours in the hours column of the table. That means that 12 hours is an input, and I'm putting it in for H. So I'm going to say C equals 6 times 12 plus 9. So 72 plus 9 is going to be $81. So this is going to be 81. Number 11 goes into what we've been working on the last few days, getting the information from an equation or a table, and then creating the graph from that. So this says Phoenix charges $8 for each yard that he mows. Create a table and then write an equation that describes the amount of money that Phoenix will earn for mowing Y yards. So for the independent and the dependent variable, you're going to decide which one depends on the other one. Well, he has to mow the yards first before he can earn any money. So no one is going to pay him until he mows the yard. So I'm going to have yards in my input and money earned in my output. And they used Y and M, so I will use the same. If Phoenix mows 1 yard, he's going to make $8. If Phoenix mows 2 yards, he's going to make $16. If he mows 3 yards, he's going to make $24. So my equation, because I'm adding 8 each time, is going to be M equals 8H. And then for my graph, I'm going to plot 1, 8, 2, 16, and 3, 24, and it should be a line that goes straight through my graph. Remember, with this type of question, you can kind of start wherever you want to start. So if you want to start by creating the table first, and then write your equation, and then do your independent and dependent variable and graph it, that's fine as well. In this one, I found it fairly clear that you needed to mow the yards first, so that's independent, and that the money earned is dependent. That's why I started with step 1. Number 12 says there was a middle school dance last Friday. In order to get into the dance, students were required to pay $6. All snacks and drinks were an additional $2 each. Write an equation that describes how much money a student would have to pay if they purchased an unknown number of snacks. So this is going to be my total cost. And then this is going to be the number of snacks. Now, if I do that in my table, I have already identified my independent and my dependent variable. The independent is the input, so this is going to be the number of snacks. And then the dependent is going to be the total cost. The total cost is typically dependent on something else happening. So that's why it goes in that output spot. In this one, I'm going to use 0 because a student can buy no snacks. So if a student buys no snacks, they still have to pay $6 to get into the dance. If they buy $1, they're going to pay this, or 1 snack, they're going to pay the $6 to get in, plus an additional $2 for the snack, so they're going to pay $8. If they buy 2 snacks or drinks, they're going to pay the $6 plus the additional cost for the snacks, which is going to be $4, so 6 plus 4 is 10. My value should be going up by 2 each time because that is the cost of a drink or a snack. So my function is going to be C equals 2t plus 6. So this is the $2 per snack. This is the cost to get in. Now I'm going to graph it, so 0, 6. So if I don't get any snacks, if I get 1 snack, and if I get 2 snacks, and then I'm going to connect the dots. Okay, number 13 just takes away the idea of the graph. So it says the wonderful Wizard of Oz is trying to make money to fix the yellow brick road, so he is charging people in the Emerald City for hot air balloon rides. The wizard is charging $18 to get on the hot air balloon, and then $9 per hour. So there's my multiplication word. What are the independent and dependent variables? Write an equation and create a function table for this situation. Remember that you can do these things in either order or in any order that you would like to. So if it's more helpful to fill in the table first, then start there. So what I'm going to do is I'm going to say, well, I have to know the number of hours that I was on the hot air balloon before I know the total cost. Okay, so the total cost is dependent upon how long I was in the hot air balloon. So I'm going to say, okay, if I didn't ride the hot air balloon for any number of hours yet, how much did I pay to actually get on it? Well, I paid $18. If I ride the hot air balloon for 1 hour, I'm going to pay the $18 plus an extra $9, so it's going to be $27. If I ride it for 2 hours, I'm going to pay the $18 plus another $18 to ride the hot air balloon, so I'm going to pay $36. And again, this should be going up by 9. Because I was able to fill in my table with this information, the hours and the total cost, I can fill in my independent and my dependent variables. So the independent variable is the number of hours and the dependent variable is the total cost. And my equation is going to start with y equals 9x, and then it's going to be plus 18. So this is the cost per hour. This is the initial fee. Okay, so that's how you know what you're multiplying by. Number 14 says Jess and Mike are riding bikes for exercise. The equation C equals 12m represents the number of calories that Jess burns in m minutes. The equation C equals 16m represents the number of calories C that Mike burns in m minutes. How much longer will it take Jess to burn 144 calories? So I've got Jess, and I've got Mike, and I've got C equals 12m for Jess, and C equals 16m for Mike. Now in this particular situation, C represents the calories, and M represents the minutes. Okay, so C is calories, and M is minutes. And I want to know how long it took, or how much longer it took Jess to burn 144 calories. So I'm going to put the 144 in for C, because C is calories. So I'm going to have 144 is equal to 12m, and 144 is equal to 16m. For Jess, I'm going to divide by 12 on both sides, and 12 is equal to m. So this is going to be 12 minutes. Over here, I'm going to divide by 16. And I believe 144 divided by 16 is 9. So this is going to be 9 minutes is equal to m. So it took Jess 12 minutes and Mike 9 minutes. So 12 minus 9 equals 3. So it took Jess 3 minutes longer. Okay, so here it's very important that you are able to identify what the variables represent, because you're going to be replacing one of those variables with a given value. Number 15 says, on weekends, Casey and Harper made greeting cards for the elderly. The table shows the number of greeting cards made after a certain number of hours. If the patterns continue, how many more greeting cards will Harper have made than Casey after 25 hours? So in this one, I've got two situations that have the same type of input. They're both hours. So I'm going to write an equation for each person, an equation for Casey and an equation for Harper. So for Casey, Casey's information is going up by 3 to start each time. So I'm going to start with y equals 3x, and then I'm going to check what I have to add. So y equals 3 times 5. Nope, 3 times 1. So I'm going to do y equals 3 times 1. That is not equal to 5, but I can get to 5 by adding 2. So Casey's rule is 3x plus 2. Now I'm going to do Harper. Harper's are going up by 4 each time. So I'm going to start with y equals 4x. And then when I check my rule here, y equals 4 times 1, well, y does equal 4. So Harper's rule is done. So I've got Casey is 3x, y equals 3x plus 2, and Harper is y equals 4x. Now in this situation, y represents the cards, and X represents the hours. So when it says, how many more greeting cards will Harper have made than Casey after 25 hours? That means that I'm putting that value in for X. So Y equals 3 times 25 plus 2, and Y equals 4 times 25. So here Y equals 77, and here Y equals 100. And then 100 minus 77 is 23 more cards. Okay, so in this one we're combining a couple of ideas together, so writing equations and then being able to identify the variables and use both equations, not just one. Number 16 says the graph shows the total cost of buying 1 large bucket of popcorn and D large drinks. Create a table of values and then write an equation from the graph that could be used to find the total cost if you buy 1 large bucket of popcorn and D large drinks. So we're writing an equation from the graph in this one. Remember that our independent and our dependent variables can come from the graph. They can also come from the data given to you in the problem. So this says the graph shows the total cost of buying 1 large bucket of popcorn and D large drinks. So I'm going to have the number of drinks. And again, my independent variable is down here. My dependent variable is over here. So I have to know how many drinks that I'm buying before I know the total cost. So again, my total cost is dependent. In this graph, 1 drink is going to end up with my total cost at $12. 2 drinks is going to put my total cost at $16. 3 drinks is going to put my total cost at $20. So now I'm going to work my way through the table. So I added 4 each time. So I'm going to start with Y equals 4X or C equals 4D, whichever you prefer. And then I'm going to check, so Y equals 4 times 1. Well, 4 times 1 is 4, but if I add 8, I get to 12. So my equation for this one is C equals 4D plus 8, or Y equals 4X plus 8 if you prefer X and Y. That is the end of the Module 7 practice test. I will post the video and the key for you to use tomorrow during class.